Knock, knock. Who's there? It's Amelia, of course. Hey there, everybody. Welcome to episode number 524 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. The man, the myth, the legend, Giovanni De Micheli, or Nanni, is joining me this week. Nanni was recently honored with the 2022 Phil Kaufman Award for Distinguished Contributions to Electronic System Design. Nanni has been a powerhouse in the world of EDA for a long time. His work has expanded the fields of high-level synthesis, logic synthesis, and network on chip, NOC, for more than 30 years. His methodologies, research, and EDA tools have helped drive huge advances in the academic field of design automation and have made a big impact on our industry through their incorporation into commercial EDA solutions. Nanni is also a big inspiration to his students and engineers across the globe. And I am super lucky to have him on my show this week. Nanni and I are chatting about what excites him about EDA today, what he thinks the next big innovation in EDA will be, and what he considers to be his greatest accomplishment so far. And you'll want to stick around because after my interview with Nanni this week, I investigate new biosensor technology developed at the University of Technology, Sydney, that will allow you to operate devices like robots and machines completely using thought control. Yep, mind-controlled robots. You'll want to stick around for that. But first, let's welcome Nanni to Fish Fry. Hi, Nanni. Thank you so much for joining me.
Nice to join you online, Amelia. That's really a pleasure for me.
Excellent. Okay, so first off, congratulations on receiving the Phil Kaufman Award. How does it feel to be part of a wonderful list of recipients?
Oh, that's a great feeling. Actually, Kaufman has been awarded to the people that they respect the most in the community, from the founding fathers, things like Hermann Gammel, who passed away just not long time ago, to the people who actually started the industry, Jim Solomon, Art, Wally. So the award is representative of a community of excellence at work in technology transfer, in achieving the environment that we have today that allows us to design the biggest systems on silicon. And so altogether, I think that that's been the best news I received just in the last few years.
I love it. So, Nanni, what do you consider to be your greatest accomplishment to date?
I think that my greatest accomplishment has been to put together an environment for design automation for networks on chips. The idea of networks on chips, NOCs, floated around the year 2000, and the notion was just to connect components on chips through packet-based communication. The idea itself was borrowing from the communication field, but to do it on silicon was fairly revolutionary. With coworkers, we put together the nuts and bolts for a software EDA environment for designing these NOCs. We started at Stanford first with Luca Benini, and then went on. Everybody took its own path. I moved to Switzerland. Luca moved first to Italy and then to Switzerland again. This idea, actually, a very good idea, got large impact. And today you see companies like Arteris that actually are leader in this domain, that actually provide full solutions for network on chips. So it's been great to see this idea growing from a simple university tool to a full environment of tools, of flows, of methods for designing the structure interconnected of chips.
I love it. So, Nanni, what excites you about EDA today?
Oh, EDA is wonderful environment to try out ideas, to think of new technologies, to execute plans and realize them on silicon, on other technologies. I think EDA has been the enabler for what we see around us. Look at how powerful our telephones, what smart cars can do, and also all the AI applications that we see today are enabled by powerful chips. And this is all due to EDA. It's been a wonderful improvement of the technology that happened over the last 40 to 50 years. And now we finally have this technology to realize our ideas. So I think it's a wonderful domain. I always try to attract students and explain to them why they should be working in EDA.
I love it. Okay, so Nanni, gazing at your crystal ball, what do you see as the next big EDA innovation?
Looking at the future, I think that one topic is understanding design in natural languages. I said it for many, many years, and now you see what happens with ChatGPT, and everybody talks about it. It would be fantastic, for example, to think of tools in which you enter design in words. Like I'm talking to you, I says, I would like a chip that does this and that. And then this new EDA tool will spit out Verilog that can be synthesized. So I think that would be a fantastic achievement for EDA to have over the next, who knows, 10, 20, 30 years. Looking also at the crystal ball, we have now EDA mainly for silicon chiplets, various ways of putting together electronic components, but we can think of EDA for things that are more complicated, like electromechanical systems. Think of the car of the future, how we can personalize it. And you're a customer, you have this idea, you like this brand, and you put in the ideas of how the design should be done, and then the product comes out of that. This would be, of course, applicable to cars, but to many, many objects that we deal with every day, not just chips.
That makes sense. So, Nanni, is there an area in EDA in particular do you think needs more technical innovation?
Oh, many areas need more technical innovation. Typically, the bottleneck is complexity. Think of verification, and that's extremely important for all electronic systems. In verification, like in other problems, really the bottleneck is the intrinsic difficulty of the problem that we have to solve. And there have been many inroads into solving problems like satisfiability, interlinear programming by using heuristics that try to deal with a solution that's exact in a reasonable time. But there is still a need for a lot of improvement. Today, still with EDA, we design chips that are as good as the tools can make them, but we can push the frontier of how good they are, the frontier of how best is the best, reaching eventually something which is close to the provable optimal solution.
So, Nanni, I know you live in Switzerland. What do you like best about living there?
Oh, Switzerland is a great environment to work. It's a very international setting that reminds me very much of California, of the Bay Area, where I was fortunate to live for 25 years. I think overall, in work and in life, what's important is just people, people, people. The people that you meet, the people that you work with, in my case, as a professor, the students that I can attract, educate, and work with. And Switzerland, it's a great environment because it values technologies, it values people, and therefore you can deal with high quality people. So that's one reason. And then, of course, I like nature. I like the environment, the mountains. I like hiking, climbing, skiing, and this is a great place to be.
I love it. All right, Nanni, it's time for your off the cuff question now. Since you haven't been on my show before, you're going to get our standard off the cuff. So, Nanni, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there. What would you have?
I would like to have Japanese food with fresh sashimi coming directly from the ocean and then some lightly fried tempura.
That sounds absolutely delicious. Let's go to Japan together, Nanni. Excellent.
Well, to tell the truth, I came back from Tokyo just a few hours ago.
Oh my goodness. I love it, and I'm so jealous. I haven't been able to go to Japan in many years now. Excellent. Well, thank you so much for your time, Nanni. It was a pleasure speaking with you.
So it was for me. Bye-bye, Amelia.
Bye-bye. Thank you. Let's talk about thought-controlled robots, shall we? So get this, a team of researchers at the University of Technology Sydney, or UTS, led by distinguished Professor Chin-Ting Lang and Professor Francesca Icopi from the UTS Faculty of Engineering and IT, and in collaboration with the Australian Army and Defence Innovation Hub, have developed a new advanced brain-computer interface that utilizes graphene-based hexagon pattern sensors to allow for hands-free and voice-free control over machines. And yes, that also includes robots. Okay, so this is how it works. Those hexagon pattern sensors developed by UTS are placed on the back of the scalp. That way, they're able to detect brain waves from the visual cortex. From there, the person wearing the sensors puts on a head-mounted augmented reality lens, which shows white flickering squares. So when the user concentrates on a specific square, their brain waves are picked up by the biosensor, and then a decoder translates that signal into commands. So how accurate is this new brain-computer interface? Well, when it was demonstrated by the Australian Army, they had soldiers operate a Ghost Robotics quadruped dog robot using this brain-machine interface. And guess what? It had an accuracy of 94% of allowing hands-free command of that robotic dog. So what's the secret of their success? In part, at least, it's the graphene. Professor Iacoppi explains this part of their research. By using cutting-edge graphene material combined with silicon, we were able to overcome issues of corrosion, durability, and skin contact resistance to develop the wearable dry sensors. So this team of researchers from UTS are very hopeful about future applications for this technology. They believe that it could be of interest to the scientific community, industry, in addition to the government. UTS professor Chin-Teng Lin sums up their research like this. Our technology can issue at least 9 commands in 2 seconds. This means we have 9 different kinds of commands, and the operator can select one from those 9 within that time period. We have also explored how to minimize noise from the body and environment to get a clearer signal from the operator's brain. We all need clear signals from our brains, right? So if you want even more information about this super cool study, I've included a couple links in the YouTube description for this episode and on the landing page for this week's episode on eejournal.com. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I completely understand. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of March 24th, 2023, I'm Amelia Dalton, and you've been fried.